All right, students, in this video, I'm going to go over notes 4.3, and it's about an angle bisector. So similar to perpendicular bisectors, we're talking specifically only about angles. So let's look at the theorem. It says that if a point is on a bisector of an angle, then the point is equidistant from the sides of the angle, which means here, this point right here, it's a point on the angle bisector, and it's equidistant to the angle, which means that here and here, these are equal. And also these two angles are equal. Okay? So then we can conclude that if AD is an angle bisector and it's bisecting BAC, then AB and BD, AB and BD are perpendicular, and also AC and CD are perpendicular, then we are to assume that segment BD is congruent to DC. Okay, so then now the converse reverses that. If they tell you that these two sides are congruent, that means that you are to assume that this is a point on an angle bisector, and also that 90-degree tells you that these are perpendicular. So for example, if BD is equal to CD with those notations, AB is an angle bisector that's perpendicular. Sorry, AB is right here. The ray AB is perpendicular to BD, and AC is perpendicular to CD. So what you are going to assume is that if that is true right here with these annotations, then this is an angle bisector. AD bisects angle BAC, and that also means that BAD, this part, is congruent to CAD, this part. All right, so let's apply that process. We have the first example right here, number 8. It's asking you to find the value of x. So we're going to look at what's given. They're giving you these annotations right here, and they're giving you the 90-degree right there, which means that this is a point on the angle bisector, because it bisects this angle into two equal parts, and these are 90 degrees, then these are also congruent. We're going to write 4x plus 30 equals 9x minus 5. And then you solve for x. I'm going to subtract the x's, subtract the 30, cancel the x's here, cancel the numbers here, and 4 minus 9 is negative 5x, negative 5 minus 30 is negative 35, and our answer is 7. So the answer for this, the value of x, is 7. Let's try number 10 now. It's a little different. This one's asking you for AD. So AD, it's this part only. So that means we're going to use this expression to find that answer. But first we need to find what x equals. To find what x equals, we apply the theorem of an angle bisector. So if these two are marked as congruent, that means this is an angle bisector, which makes these be congruent because of that 90-degree. Then we're going to write an equation of 13x minus 4 equals 8x plus 11. And then we solve for x by moving the x's to one side and the numbers to the other. And this results in 13 minus 8, which is 5x, and 11 plus 4, which is 15. Divide by 5, x equals 3. So now that we know x, we're going to plug it in there. We're going to do 13 times 3 minus 4. 13 times 3 is 69. No, never mind. 39 minus 4. So then that results in 35. So 35 is the answer for this problem. Number 12 is asking for this analysis and to find the measure of angle FGH. So let me color coordinate that so you can see what FGH is. FGH, it's asking for this whole angle, all of this together. So similar to perpendicular bisectors, we are going to find what one of these is and then double it. But to find what one of these is, we need to find x. So let's do some analysis here. We notice that if these two are marked as equal, then we can assume that this is an angle bisector because it's cutting this angle in half. So therefore, these two angles are equal to each other. And we're going to start with that. 2x plus 20 equals 5x minus 37. And then we solve for x. Okay, so that gives you negative 3x and negative 57. So x equals 19. And then now we have several methods. Some of you like to combine the two expressions into one and then plug in the x. Some of you want to plug it into one of these expressions and then double it, or plug it in separately and then add them. So because they're congruent, we could just pick one. So let's do 2 times 19 plus 20. That's 38 plus 20, which is 58 degrees. One of these angles is 58 degrees. So the other angle has to also be 58 degrees. So we could just double 2 times 58, and then that gives you 116 degrees. That will be the final answer for this problem. These two angles combined will be 116 degrees. All right, for number 9 and 11, you could pause the video, try it on your own, and then check if you got it right. It's just the practice of 8 and 10 again. So let's do that quickly. You can pause the video, like I said, and just press play when you want to check it. So right here, the angle bisector, it's dividing these two angles, or this whole angle, into two equal angles because of these annotations and the 90 degree. So we're going to write 5x minus 11 equals 8x minus 41. If you can't see the 1 because it's folded, just make sure you see that it's a 41. So we're going to subtract 8x, add 11, and that's negative 3x equals negative 30. Let's see, yep, negative 30. Divide by negative 3, and x equals 10. So x is 10. It's asking for x. We're done. Let's try the next one. XWZ. So XWZ. XWZ. So this angle right here. All right, so we're gonna see the annotations here and say, oh, it's also bisected by this line right here. So we're gonna assume that these two are equal because it's bisecting them. So 3x plus 3 equals 8x minus 32. Negative 8x minus 3. Negative 5x equals negative 35. And x equals 7. But this one's asking for the measure of the angle, so now we're going to go plug it in. 8 times 7 minus 32.
That is 56 minus 32, which equals 24. All right, that concludes the notes on angle bisector. I'm going to teach you also in-center all in one day, or I taught you angle bisector and in-center in one day. So I'm going to make a separate video for in-center. Make sure you watch it.